I will be discussing simplifying radicals, and I'm going to also mention how to rewrite an expression in either radical form or exponential form. For exponential form, you may hear other terminology such as fractional exponent or rational exponent. It means the same thing, and I will explain that in examples 4 and 5. So let's do a quick review. The index on the radical is what appears right on top of that radical. So for a square root, you typically don't see, well, you won't see that number 2. It's understood to be a 2 there. And what that simply means is whatever is under the radical, which is known as the radicand, has to have 2 of the same thing in order to come out from under the radical. If it does not, it has to stay under the radical. For instance, this says x squared. So if I were to separate it, that's really x times x, right? Which is going to come out as a pair x. So it no longer stays under the radical. The simpler way, I believe, is to just take whatever this exponent is and divide it by your index. So in this case, x would be x squared divided by the index of 2, which is still x to the first, and you don't have to write the 1, you just write x. If my index, however, changed, and let's say it's a 3 now, that's known as a cube root. So for my cube root, it's the same concept. Except I just need 3 this time, 3 of the same thing to come out. So x cubed is really x times x times x, which of course that's 3 x's, right? And I need 3 of those to come out from under that cube root. So my answer is simply x. Again, I think if you just take the exponent of what's under the radical and divide it by your index, so 3 divided by 3, you still will end up with the exact same thing, which is x to the first power. So it is important to pay attention to your index. Simplifying will take place for the first 3 examples. So the first 2 are going to be square roots, and then the third one is going to be a cube root. So I'm going to show you multiple ways to do this. What I would do for a square root, that simply means, like I said a few minutes ago, you want to take 2 of the same things in order to bring it out from under the radical. That's my whole goal. I don't want to leave a lot of things under the radical. So if I'm trying to find 2 of the same thing to give me 28, meaning what number can I multiply times itself to give me 28, I can't find anything. But if I break this out into factors like 4 times 7, I recognize that if I were to take the square root of 4, well, that will give me a pair of 2s, because 2 times 2 will give me that 4. However, with this 7, I can't do anything with that. So that means it remains under the radical. I also notice to the side that I have x cubed. So what I'm going to do is just write it over here, and just to demonstrate what it looks like. X cubed is really x times another x. And again, I need for my index, this time my index is a 2. It's understood to be a 2. That means I need a pair in order for that to come out. Well, what happens is I'm still left with 1x. That x has to stay under the radical. The simpler way for me is to take whatever that exponent is and divide it by my index. But I see that 3 cannot be divisible by 2 without leaving something left over. So what I'm going to do is take the multiple that's closest to 3 that is divisible by 2. So not going over 3, but it has to be before. So I am going to take x, and then 2 is a multiple of 2. But then I still have, like I said, that 1. Well, I'll just write it out so you can see it. I still have 1x left over, because 2 plus 1 is going to give me that 3. What I would do is then simplify it. And once I simplify it, I end up right back where I was. I have 1x, but I'm multiplying it times that x that cannot come from under the radical. So same answer, I'm just doing it 2 different ways. All right, I have to keep track of that. So I know over here, I have an x that can come out, and then the square root of x. This can get messy, so come up with your own strategy of how to make it neater. All right, so then the other one, like I said, let's go back here, is going to be, I still have an index of 2 here, but if I just want to see what it looks like. Y to the fifth is y times y times y times another y times another y. And now I want to look for how many pairs can I bring out? 1, 2. I see that I'm left with 1 left over. So that is going to be y squared. Do not put 2y because that's not 2y. It's y squared. And then I'm left with that 1y that cannot come from under the radical. Or y, and then the closest multiple that is divisible by 2 that does not go past 5 is 4. And then I'm left with that 1 that's left over again. These two numbers have to add up to equal what I started with. So 4 plus 1. All right, and now if I simplify it, I end up with the same thing, y squared, but y to the first is not enough to come out from under the radical, so I have to leave it under. Let's go back over here, and it is, you definitely have to keep up with this stuff or it can get confusing. So my final answer is going to be, let's use this one. It's going to be, I use numbers first. So I circled the pair, I circled 2. So 2, and then I know I have 1x and I have a y squared. Those can come out. What's still under the radical, starting with the number, is 7, 1x, and 1y. So I want to double check this to make sure this is my answer. The easiest way for me is I knew whatever this number was, I had to double it. So 2 times 2 is 4. What's left over is that 7. So 4 times 7 is 28. So I know my numbers are correct. I do the exact same thing for my variables. So x times another x, and then what's left over is an x. So that's going to leave me, if I know the rules, that means I'm adding my exponents. So 1, 2, 3, x to the third power. Okay, so far, so good. And then I want to do the same thing with y. For my y, hold on, this is getting messy here. I am going to take y squared, and I had to double it. So y squared times another y squared, and then what I'm left over with is 1y. If I add my exponents, that's 2 plus 2 plus 1. So I should have started with y to the fifth, which I did. So I know that my answer is correct. That's how you double check it. And it's worth it to go back and double check it. Now I'm going to show you another way using your calculator. Now the variable part, that's not going to help you, but as far as the number part, this might be something to help you check it as well. So what you want to do is, let me just rewrite the number part. It was the square root of 28, right? So that's what I'm going to put here. Using square root of 28 in the calculator. Locate my calculator. What you want to do is you want to go to your y equals button. Your radicand is the number under the radical. So I'm going to take 28. I'm going to divide it by x. Now, in this case, I have a square root, so it's going to be x squared. Then I'm going to go to second graph. And what I'm looking for is the number, the first number that starts with like a 0 point something. So once I go down to that, in this case, it happens to be 6. That's going to tell me to scroll back up and find the whole number, the next whole number under the y column, which is 7. So my answer is going to be 2 radical 7. So let's just double check it to make sure. Well, we already looked at it. We wrote it a few minutes ago. Hold on. Let me just go back up so you can see. So we wrote 2 radical 7. So let's verify it though. So we're going to go to second quit. We said that we want to find the square root of 28. Well, we know in this type calculator, it's going to give us a decimal. So the easiest way to do it, to check your work, is to just type in 2 square root of 7 or 2 root 7, however you want to say it. And then you want to double check to make sure that those decimals do match. And you see they do match. So that's how you can check that type problem. So I wrote these steps out for you over here. So if you want to take a moment to pause, copy it, however you want to do it, definitely go to that last step and verify that that is in fact your answer, okay? So for example 2, now this time we have a number on the outside. So you have to pay attention to that. Now let's just say, again, we're trying to take the square root. We're trying to find a number that if I multiply it times itself, it will give me 54. I can't readily think of a number like that, but I do know that if I multiply it 9 times 6, that 9 actually has a pair of 3s. 3 times 3 is 9. Can't do anything with that 6. We have a 3 times 2, but they're not pairs. So when that happens, what you do is you just leave this number under the radical as is. So you still have to multiply that 3 times 2 to put it back to that 6. And now we're going to go back over, and I'm not going to take the time to write out the x's and the y's and then circle the pairs. I'm just going to do it the way that I think is easier. So I'm going to take x squared, and I'm going to divide it by the index of 2. So that leaves me with 1x that can come out. Y cubed is really y squared divided by 2 times 1y. Again, the top 2 numbers have to add to equal what I started with. And I grab that 2 because that's the closest multiple that is before my exponent that's shown. So this results in y, and then I have to leave one of the y's under the radical. The next one is going to be z to the 4th, which is divided by 2, and this comes out as z squared. So all of those can come out except for that one y. So now I go back to my original problem, and I see that I have a negative 4 that's already outside. Anything that I'm bringing outside, I have to multiply times what's already outside, including a variable if there was a variable outside. So I'm going to bring out a 3. And then I have the x that I can bring out. You know what? I'm just going to go ahead and simplify this. That's going to give me negative 12. So negative 12, I can bring out one of the x's. I'm looking over here. I can bring out a y, and I can bring out a z squared. What I cannot bring out is numbers first, that's 6, and the y. So this is my final answer. If you are using the calculator steps, you'll have to come back and double check that negative 4 that's already on the outside. So this is what it would look like. Let's go back to our calculator. And we can clear this out here. So if anything there is there, just clear it out. And then we want to do the square root of second x squared. No, we don't. Sorry about that. You want to do 54 divided by x squared. And then you want to go to second graph. Look for the number that has in the y column that starts off with 0 point something. Once you find that number, go all the way back up until you find a whole number. Over to the left is your x column, over to the right is your y column. So it is, the answer is 3 radical 6. That's what we said, right? If we look here, that's what we said. We said 3 radical 6, but we had a negative 4 on the outside. So we had to account for that. Our final answer is not going to be 3 radical 6, okay? So keep that in mind. But that is useful using a calculator to know this. So now we're going to go to second quit, and we can do negative 4. Actually, yeah, we could, but I don't want to do it that way. Or do I? Yeah, we're going to do that. Negative 4 and then radical 54, because that's what we started with, right? This is what the decimal should be. So now we want to try to do negative 4. Well, we don't even have to do negative 4. We already know that it's going to be negative 12. So negative 12 times radical 6. And it should be the same answer, which it is. So what I did was, and you could probably do it this way, I didn't try, times the 3 root 6, which is what we found in the table. Yes, it gives you the same answer. So whichever way that is most comfortable for you, that's the way that you can go about doing it. Okay, let's go back to example 3. This time we have a cube root. Now, a cube root means we have to take whatever is under the radical, and we have to have 3 of the same thing in order for it to come out one time. Well, for 128, I don't know of a number that you can multiply times itself 3 times to give me 128, but I do know that this is divisible by 2. It's an even number. So 64 times 2, let me just make sure. Yes, that's correct. 64 times 2 gives me 128. And if I further simplify this, again, I'm looking for 3 things this time. So 4 times another 4 will give me 64. And I can't do anything with this 2, so I'm going to have to leave it under the cube root. Now, pay attention, because it's going to be tempting to write this as the square root of 2. You have to pay attention. That index has to come out in your answer. So if it's a cube root, you have to put a cube root. Now let's go over to our variables. I have the cube root of m, which again is m times m times m times m times m times m. Oops. So here I can clearly see I have 2 groups of 3s. So that means I can bring out m 2 times. And then if I go to my next one, I have the cube root of n times n times n times n. This time I can bring out 1 group of n's, but I'm left with the n that stays under the cube root. So n times the cube root of n, and then finally the cube root of p 8 times. Now you see what a hassle this would be to sit here and try to do this, writing all this out. What if this said p to the 81st? Are you going to sit there and write 81 p's? Nope. So what you want to do is try to group all of your 3s together, because I'm basing it off of my index. And I see that I can bring out p squared, p cubed, p squared, sorry. It can get confusing. So p squared, and I'm left with the cube root of p squared, because there's still 2 p's in here. Okay. The easiest way, again, for me, is to just take this m, and I want to divide it by the index. Let's go back over here so you can see it, of 3, because 6 is a multiple of 3. So I'm going to end up with m squared. If I did the same for n, well, 4 isn't a multiple of 3. So I want to take the number that's closest to it without passing the exponent 4, which is 3. And then I'm going to multiply times what, 3 plus what will give me 4. So it's 1. That's how many that are left under the radical. This is going to give me what I said over here. 1 n, and then I'm left with the n under the cube root, and then the p to the 8th power. The closest number that is a multiple of 3, so p, I need something here, and it's not 8, it's not 7, it's 6. But then I still have 2 p's left over, because 6 plus 2 equals to 8. Well, p to the 6 divided by 3 is p squared, which we already said here. And then I'm left with the cube root of p squared. You choose which way makes sense to you. So my final answer is going to be, I'm going to take out what I circled, 4, as a number. And then when I look at my variables, I can take out m squared, n, and p squared. What's left over is the cube root. That part is important. And then I go back to my numbers. I had a 2. And if I go back to my variables, I have an n and a p squared. N, p squared. Okay, so what's going on is now I can double check it. If I go to my calculator and I clear all of this out, because that's just too busy for me. This time I want to take 128 and I want to divide it by x cubed, because I'm using a cube root. So I can go to math, and then cube is number 3. So I can just click number 3, and it'll show that, or I could have used the little caret button that's under clear. Now go to second graph and you do the exact same thing. You want to look to where your y starts with 0 point something, and then you go back up to where you have the first whole number. So it's telling me my answer is going to be 4 cube root of 2. If I look at what I've already wrote over to the left, that's what I have as far as numbers, 4 cube root of 2. Let's double check though to make sure that we're on the right track. If I wanted to check my original cube root, go to math. Number 4 is the cube root. And then I type in 128. The answer is a decimal. So let's go and see if the answer 4, and then again, math, number 4, which is the cube root, 2, does it equal the same decimal? It does. So I know that that is my correct answer in terms of my numbers. In terms of my, if I want to double check my variables, I had to take m squared and I had to multiply it times itself 3 times. So when you take an exponent and raise it to a power, you're multiplying. So that is m to the 6th power. That's what I started off with. So I know I'm on the right track with the m. Then I go back and I do the same thing for n. On the outside, I had one n, but I had to raise it. I had to multiply it times itself 3 times. I still had an n left over, so times another n, and I should end up with n to the 4th power, because 3 plus 1 is 4. That's what I started with. So I know I'm on the right track there. Then I do the exact same thing for p. On the outside, I have p squared, which is, I had to multiply it times itself 3 times. So that's going to be p to the 6th power times what was left over under the radical, p squared. If I add my exponents, it's p to the 8th power, which is what I started with. So that is actually my answer here. All right, the next two should be fairly easy because all we're doing is rewriting from one form to the other. So write an expression in radical form. If you ever see a negative sign there, that's telling you that you're going to have a fraction. So you're going to have 1 over something. 1 over. Now, your numerator, your top number always goes with your radicand, because that is your radicand. And since we're writing it in radical form, that means we're going to have a radical. So that's my radical. The 5n goes together, so I'm going to put it in parentheses together, and I just said the top number goes with it. Well, the denominator is your index, so that's what's going to go on your actual radical. This is the way I typically write it, but I have seen it shown as 1 over, and then they'll take the entire cube root and then raise it to that power. Either way is acceptable. I just prefer the first way. So for the second one, I don't have a negative exponent. And I mentioned this earlier that sometimes it's referred to as a fractional exponent or a rational exponent. So just know the terminology. So in this case, I would just simply take my numerator and attach it to my radicand, because what's in the base of whatever I'm working with is my radicand. So that will be 6x raised to the 5th power. And then my denominator is my index. For the purpose of writing it in radical form, go ahead and put the 2 there. But typically a square root would not have that 2 there. And then, like I said, or you could write it as the square root of 6x, and all of that is raised to the 5th power. So those are ways that you would rewrite an expression in radical form. Well, let's say that it was given to you already in radical form, and now you wanted to express it in exponential form, or those 2 terms that I told you before, fractional or rational exponent. Well, I already know for that first one, I just said that if it is if it's a fraction, it's going to be a negative exponent. So whatever is under the radical, that is my base. So I know it's going to be 10a. My fraction is a negative because it is a fraction, not my fraction. My exponent is a negative because I have a fraction in my problem. And then whatever is associated with my radicand, that is going to be my numerator of my fraction. And my denominator, don't think that it's going to be 1 because somebody's going to try to put 1, is going to be whatever the index is. It's understood that there's a 2 there. So this is my answer. It's going to be, but let me correct that. This is not my answer. Since I have a 10 and an A that are next to each other, I have to make sure I use parentheses. This is extremely important because that tells me that the entire answer is raised to the negative 3/2. That is very important. You have to use the parentheses. So for the next one, it's going to be the same concept. My radicand is 5n. So just go ahead and put it in parentheses so you don't forget. The top number, or the number that is raised to, the power that is raised to, is my fraction numerator. And then my index is my denominator. I don't have a negative sign because it's not shown as a fraction here. See the difference between A and B? Okay, so that is how you would actually write those answers. What's important? You have to make sure that you put that base inside of parentheses. Have a great day.